Hello and welcome. This is Kamal Mahmood, and today's topic that we are going to talk about is OSI model. So let's head over to the next slide, which is talking about the agenda. So since this is going to be the beginning of my program, so that's why I'm going to take a little bit time over here and will unfold some topics that I want to cover in this program. So as you can see, this module is about OSI layer, or this program or this session is all about OSI layer. So I will be talking briefly about the 7 layer of OSI model. Okay, and when we will hit this topic, I will be briefly talking about each and every layer. But apart from that, as you can see, I have some another major topics, and one thing I missed over here. The first topic that I'm going to hit after OSI layer is analyzing using Wireshark. If you're already familiar with this tool Wireshark, then that is good enough. If you're not, then I'm going to give you a detailed overview how we are going to use it and why do we need to use this analyzing packet tool. Okay, so basically whatever I'm talking in a OSI layer, I will be proof using Wireshark. Okay, the second major topic that we are going to hit is troubleshoot. You might be a very good network administrator or network engineer. If you don't know how to troubleshoot a network, I don't think so you are going to make it. Okay, so this is the idea, agenda, and objective of the JSS. Okay, to make you prepare for the future. Okay, if we want, we just could teach you OSI layer and can finish the this session over here, but we do not want like this. Okay, we want to make to prepare for the future. So that is why troubleshooting is one of the very important aspect in the life of network engineer. That is why we are going to cover troubleshooting as well. So this is going to be the program for the beginners, for the so that is why we do not want to go a lot in detail. So we will be just scratching the surface of every the topic that we are going to cover in this session. The third very important aspect is network security. And you as IT nerd, network engineer, system administrator, or even having IT knowledge, everyone has a clear idea about what network security is. And if you are even a standalone user for this computer, you might be facing this issue on day-to-day basis. So that is why we are adding network security concepts in the same program, so you have a very good understanding how you are going to face cybersecurity or network security issues. Okay, the fourth major topic that we are going to hit is cloud. Why? Because this is where things are moving. Sooner or later, everything is going to transform into cloud. Okay, although this transition is very slow, but you can see, the company that currently I'm working in, they are 100% on cloud. They have like 10% data center physically in their location, but seriously 90% they are using AWS and Azure. So just you can imagine the power of cloud. So that is why we have included this cloud section as well in the same program. So as you can see, four major topics: one, analyzing Wireshark, and the second one is troubleshooting, third is network security, and fourth is cloud. Okay, because as I said, the JSS want to make you prepare for the future. The last but not least, common interview question and answers. So from the perspective of OSI layers, whatever the common interview questions appears, I'm going to list down in the last slide as well. And you As an assignment, you have to find those answers and you need to submit to JSS. And this agenda we are going to follow throughout this program. Okay, so you have to make it yourself ready. And this session is going to be the lengthiest session, because the opening session is always going to be lengthy. So I am planning to divide this session into two portions. Okay, so you do not get bored. So let's head over to the next slide, which is talking about the OSI model, or what is OSI model. So first thing first let's read about this paragraph that I prepared for you. The open system interconnection OSI model describes 7 layers that computer system use to communicate over a network. It was the first standard model for a network communications adopted by all major computers and telecommunication companies in the early 1980s. So you can imagine how old this OSI model is. OSI is a model or system that help you break down network functions. So as you can see over here on your right side, the seventh layer of the OSI model is application layer. Okay, either you can start from bottom up approach, or top down approach. Okay, whatever you is feasible for you, you can do it. But I will start, since this is the first one, so that is why. Although physical is the first one from the bottom, but this is all always it is represented. The application always comes first, but it is going to be your seventh layer of OSI model. So this application is 7 layer. Then we have presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. If you are if excuse me, if you are saying this for the first time, then you have to remember this by heart. Okay, but sooner or later, when you will get familiarized with every layer of this OSI model, trust me, this thing will be on your fingertips. You will immediately something pop up in your mind that, yeah, this thing works at transport layer. Okay, yeah, this thing or device works at network layer. Okay, and I'm very hopeful that after the end of this session or the program, you will be having very clear understanding of each and every layer. Okay, so in the first para, it is saying this is the OSI model. Describe the 7 layers as I have shown here. It the standard model for network communication, how it happens. For example, we have two computers and somehow they are connected with some wired cable. Could be cat 8, cat 6, or whatever might it be. When this computer wants to communicate with this computer, they are going to follow these OSI layer model. Okay, and when I will be describe each layer, then you will be having very good understanding and idea. But this is just a flyby overview. Whenever you are going to communicate over a network, you always have to have this OSI layer in your mind. OSI model or system that help you break down network functions. So as it is mentioned clearly over here, breakdown. If you have heard this word, divide and conquer approach. So basically, uh, instead of giving one layer, one big layer, and then you will end up achieving nothing. What they did, they break down these all one layer into multiple layers. If they want, they could have single layer. Yeah, but why? Because they have divided these all into sub layers to make you understand at every layer what is happening and how you are going to troubleshoot uh, particularly that layer. Okay, so that is the basic idea behind having the breakdown. So you can divide and conquer. I hope you get the idea. Okay, so I have given a very layman example over here. If you are going to construct one house, how you are going to construct? Of course, you need to break it down. First thing first, as you can see, this is going to be the first. You are going to purchase a land, and then you are going to put some foundation. In the second step, you are going to stand a structure over here, as you can see over here, and then you are going to construct. In the third step, you are going to install some insulation, waterproofing, and then electric kind of stuff, and then as you can see, the structure has been built. In the final step, the whole building or the whole home has been constructed, and this is going to be your finished touches. On the same basis, we are going to construct our hardware devices as well. So that is why OSI layer comes handy. For example, if I give you example, you are going to open one hardware manufacturer company that is basically going to manufacture these cables. Okay, but how on earth you are going to make this cable compatible with this switch and compatible with this network interface card? How? Of course, you are going to follow some governing body, or you are going to follow some rules that is governed by ISO, not to confuse with OSI. OSI, Open System Interconnection Model, whereas ISO is International Standard Organization who govern these 7 layers of OSI models or the rules. And basically what happens on each layer, on the basis of that, you are going to follow those rules. You are going to manufacture your this cat 8, cat 6, cat 9 cable that will be compatible with these Cisco switches or network interface card. If you're not familiar what NIC card is or what Cisco switches switches are, don't worry. This just imagine this is just like some hardware device, or you can, in a short or layman example, you can say this is some mini computer. Okay, even if you want to manufacture a computer, you always have to follow some rules, and those rules governed by these ISO, the organization. So you always have to follow the rules. Okay, so this is the whole idea having OSI model. Another aspect is troubleshoot. I'm going to give you one scenario, the real example when I joined the company for the first time, and I received a call from the employee. He said my internet is not working. So just immediately went over to his desk and I checked. Yes, the internet was not working. You know, the first thing that came to my mind is this OSI layer approach. I went to this layer first. Physical layer, when I will be talking about the physical layer in the next slides, this is talking about the physical things like cables. Okay, so first thing came to my mind is, do we have proper cabling for this user or employee? So when I checked the RJ45, it was unplugged. Okay, so instead of wasting my time troubleshooting all above layers, I just jumped over to the physical layer and just checked the cables or even the power connectivity. Okay, so this is the whole idea of having OSI model. So you have a very better understanding and the approach when it comes to troubleshooting. So I hope you get the idea. So let's head over to the next slide, which is actually going to start our seventh OSI layer, which is application layer. So first read about the paragraph. It is saying the seventh layer of OSI model is application layer. This is the only layer that directly interacts with the data from the user. It which means that your end user, employee, uh, the user, or no matter who is he or she is, directly connected with your application layer. From there, he or she is going to give input. So basically, user is going to input the data through various application at this layer. The input application could be, so this could be software application like web, browser, email clients rely on the application layer to initiate communications. Okay, but it should be made clear that client software applications are not part of the application layer. Rather, the application layer is responsible for the protocols and data manipulation. That software relies on present meaningful data to the user. And at the 7th layer, the most common protocols that are being used are HTTP, HTTPS, SMTP, then SSH, FTP, POP10, and many more others. Okay, so these kind of protocols are being used on application layer, which is going to be your 7th layer. So basically, what this paragraph is trying to say, your user is going to directly involve interacting with your application. This might, this could be like web application. This could be like some mail application, email application. Okay, this could be something like file transfer application, FTP server, or could be anything. Okay, so user basically providing its input to these applications. But all application does not come under layer 7. How? For example, we have some games sitting on this computer like solitaire or could be chess. Okay, so when you are playing these games, do you think you are going to internet? No, you are just playing these games locally on this computer and you are going to close this game. But on other hand, when you are going to use web browser, on the URL box you are going to type www.jobskillshare.org. As soon as you hit enter, what is the next thing it is going to happen? It is going to reach some server that is related to job skill share, and it is sitting far away from your location. So it means you are going your boundaries to reach out this server. So it means in order to reach this server, you have to follow some rules, some applications, or some devices. Or for that, that is why it is mentioned that all application does not comes under OSI 7 layer. So whenever you are going to go beyond your computer, maybe even in your local area, even in your local area network, if you are going to hit some file transfer protocol, FTP server, okay, you have to follow these OSI layers. But if you are playing some games like solitaire, chess, that is locally installed, you are not going to follow OSI layer. So this is what is trying to say this paragraph. Okay, I hope you get the idea. So seventh layer of OSI has to do with application layer. The sixth layer of OSI is presentation layer. So first read about the paragraph. Sixth layer of the OSI model is primarily responsible for preparing data so that it can be used by the application layer. Okay, so whatever methodology will be happened on sixth layer is going to interact. Basically, it is making itself prepare to interact with the application layer. So basically, layer 6 makes the data presentable for application to consume. The presentation layer is responsible for translation. This is going to be very important. Translation, encryption, and compression. So these three things happens at presentation layer: translation, encryption, and compression. And we know what compression is like. If we correlate it with the zip or WinRAR, it is going to compress that file. Encryption, whatever the data is, it is going to encrypt into. For example, I have character A. It is going to, let's say, I forgot what A stands for in ASCII characters, but let's say it is 97. Okay, so it is going to encrypt. Then this is the translation. So as you can see over here, it is going to translate whatever the image we have. This is in the JPEG format. It is going to translate into this gibberish data, and then vice versa. Gibberish data is going to translate into this JPEG format. Let's suppose this was Microsoft Windows and this is Mac operating system. These both should know or understand the idea of JPEG format, JPG format. Let's take this example. Is if my Microsoft computer knows what is JPEG format, it can translate this gibberish into JPEG and JPEG into gibberish. Whereas when I'm going to transfer this file over a Mac computer, and unfortunately my Mac computer does not have understanding about JPEG format, then it is not going to translate from gibberish to this JPEG format. No, it is just going to give me another gibberish data, just like this. So it means both computers should have a language of love. Basically, they should have understanding about how to convert this format to JPEG format and vice versa. So two communicating devices communicating may be using different encoding methods. So layer 6 is responsible for translating incoming data into a syntax that application layer of the receiving device can be understand. Okay, so whatever it is going to translate, the application layer, which is at the seventh layer, should have a clear understanding of this syntax. If the devices are communicating over an encrypted connection, layer 6 is responsible for adding the encryption on the senders and as well as decoding the encryption on the receiver's end, so that it can be present the application layer with unencrypted readable data. So as I said, encryption is also happens at the sixth layer. So whatever the data, for example, I'm surfing the web using www.jobskillshare.org. So whatever the contents or the page I'm going to receive on my computer will be in an encrypted format if it is secured, SSL or HTTPS if it is using. Okay. So both parties, by the way, these SSL keys will be installed locally in my computer whenever I'm going to serve some secure website. So those SSL security encryption keys will decrypt my whatever the data is coming from job skills here, and it is going to show me the website. So this is basically I'm going to give you a very advanced knowledge, but no problem. You just keep it. If you can digest, that is good. But this is whole idea of having the presentation layer. It is going to translate. as I mentioned over here, encryption like SSL kind of things, HTTPS, the secure things it is going to encrypt and decrypt, and the compression. So this is what presentation layer is used for. Then we have a session layer. As the name suggests, session, we are going to create a session for some time of period. So let's talk about the paragraph. The fifth layer is responsible for opening and closing communication between the two devices. The time between when the communication is open and closed is known as session. The session layer ensures that the session stays open long enough to transfer all the data being exchanged and then promptly close the session in order to avoid wasting resources. This layer is also responsible to synchronize data transfer with the checkpoints. Okay, so what this whole paragraph basically is talking about, whenever, for example, this is my laptop and I am trying to access the website www.jobskillshare.org. As soon as I hit enter, it will reach to the server. Server will send some cookies which will be having information of session, that how long we will keep this session connected. And if the session cookies are saying unlimited time, then no matter you open that session for maybe 2 days, 3 days, session will not be closed. But have you ever came across with the bank websites? If you keep that session open for 2 to 3 minutes or maybe 5 minutes, depend on the session cookies, it will be teared down automatically. The session will be disconnected automatically after some time. So that is why session layer is very important aspect. As you can say, manage connection between client and server. Okay, so it will keep connection open unless until you are using that website. Maybe you are doing some kind of transactions. So as you will proceed with the transaction, the session time will be incremented. But if the session is idle for some time, it is going to tear that session. So this is the whole idea having the session layer. So here is the example. If a system is sending up 800 pages, adding checkpoints. So this is it is going to give me the idea about how the checkpoints works in session layer. So for example, if you are sending 800 pages, adding checkpoint after every 50 pages is recommended. This ensures that 50 pages unit is successfully received and acknowledged. Okay, so we have to basically send all 800 pages, but checkpoint is added after 50 page. So once these all 800 pages will be transferred to this server successfully, then our session will be closed. Okay, so this is the main idea of having a session layer. So let's head up to the next slide, which is talking about transport layer. And as you can see, I didn't have enough space, so I tried to squeeze all into a single slide, because time is very crucial and we don't want to waste your and mine time as well. So let's very quickly talk about the transport layer. The fourth layer of the OSI model is the transport layer. So sorry, I have said fifth layer. This is the fourth layer. Okay. The fourth layer of transport is the transport layer. As the name suggests, you are going to transport some data. This is very important. For example, this is my client PC, this is my server PC. If I want to transfer some file to this server or vice versa, we are working on a transport layer over here of the OSI model. Okay. So layer 4 is responsible for end-to-end communication between the two devices. So as you can see, this is end-to-end communication. So our final piece of information is being transmitted or received. Happens at transport layer. This includes taking data from the session layer. So as you can see, we took the data from the session layer. So this is how all layers are dependent on each other. If you are thinking that you can take out one layer from the OSI model, this is not possible. So this includes taking data from the session layer and break it up into the chunks called segments. So this is going to be the very important thing, segment. Because if you have, let's suppose, 1 GB of file, and do you think you are going to send 1 GB file at once to this server? It is not possible. What you are going to do? You are going to break it up into a small chunks. So this 1 GB data, you are going to divide into, let's suppose, 10 MB, 10 MB, 10 MB, and so on. So first 10 MB will be transferred, then second 10 MB will be transferred, third, and so on. So this is what it's saying. And these, whatever these things are, these are called segments. Okay. So before sending it to layer 3, the transport layer on the receiving device is responsible for reassembling the segment into the data the session layer can consume. Okay, so as I said earlier, 1 GB data that is divided into chunks will be sent to the server, and server will be responsible to reassemble these data. For example, it is tagged with 1. This is tagged with 2, 3, 4, 5. Okay, so when this server will receive these segments, it is going to reorganize these packets in a sorted fashion: 1, 2, 3, 4, 5, 6, and so on. So that is why we receive the data in accurate form. So this is the whole idea. So at transport layer, whatever the PDU, by the way, on every layer, whatever the data is being transmitted is called PDU, protocol data unit, or packet data unit, protocol data unit, packet data unit. Okay, so whatever the data is being transmitted is called PDUs, and then this PDU when it reaches transport layer is called segment, and when we will reassemble this one here, this PDU, it is going to be called data once again. Okay, so this is the whole idea. The transport layer is also responsible for flow control, error control, and there is another thing called windowing, sliding window, and these all things we are going to cover a lot in detail when we will hit this uh, TCP or UDP section. Okay, so flow control determines an optimal speed of transmission to ensure that the data or ensure that a sender with a fast connection does not overwhelm as a receiver with a slow connection. So let's say client PC is fast enough. It has a very good speed, high processor and RAM, memory. It can just handle ton and ton of data in a seconds. Whereas our server, this is very slow. So let's say if I want to transfer 1 GB data all at a sudden. So what will happen? Server will be down. It will be overwhelmed. It will say that I cannot handle your query at this speed. Okay, so this is also one of the feature happens in the TCP or the transport layer called flow control. And the server will determine how much data you have to send me at what speed. Not the sender will decide. The receiver will decide at what speed you have to send the data. Okay, so this is the main idea behind it. Transport layer protocols include the transmission control protocol TCP and the user datagram protocol UDP. Also, the ports also used as this. For example, well-known ports like 80, 8080, 443, and random ports. That is why I have mentioned here this thing, the chart, the port number. Just by looking, you if you want to be a very good network engineer or network administrator, you have to focus on these remembering these port numbers instead of FTP, SSH, telnet, and these kind of thing. Okay, just by looking this 53, suddenly this thing came or pop up in your mind that this is they are talking about DNS. If I'm talking about 110, it means it is talking about the mail exchange server protocol, which is POP3. Okay, so you have to be clear on understanding port numbers. So if we are talking about the service, which is file transfer protocol, FTP. FTP is basically used, for example, if a client want to send some files over a FTP server, then FTP server will open two ports like 20 and 21 for the client available. So client has very clear understanding that 20 or 21 belongs to FTP. Then this only going to transfer the data. Okay. Then similarly, we have SSH. And by the way, we have telnet here as well, if it is not there. Yes, telnet 23. It is mentioned there, it unsecured, not secured, by the way. In back old days, whenever, by the way, telnet, why we use telnet? For example, we have this computer and I am sitting far away from this computer in some another department and I want to access my server. So I will be using maybe telnet, although we use RDP for accessing Windows Server, but just for the sake of simplicity, we are using telnet to access my server. So basically, to first of all, the server should have 23 port open to accept the queries. So I will telnet using this port, and it will send me reply back, and then I will have the connectivity with my server. But in the telnet, what used to happen, whatever the data username or the password is being sent over this wire are clear text. Okay, so whatever information I'm going to send over telnet, this is clear text, and if some hacker is sitting in between, they can have a hand on that password and they can access my server. So that is why secure shell came into play to secure our connectivity. So secure shell is use port number 22. So this time my server will open port 22, and same way like we access using the telnet, we are going to use SSH to access my server, and it is going to provide me the access. And this time if some hacker is sitting over here, some bad guy is sitting over here, and they are trying to access this my whatever the data or the contents, it will be encrypted and they cannot decrypt. So this is the main idea. So I'm not going to waste my time describing these all ports and services, but just I'm going to give you an idea. Then similarly, telnet use 23, a simple SMTP use 25, DNS use 53, HTTP use 80, and this is not secure as well. That is why 443 HTTPS SSL TLS is being added to secure our web communication. Similarly, we have POP3 110. 123 is used for network time protocol NTP, and then this 143 is for internet message access protocol, and 161 is used for SNMP. Uh, the two main transmission protocols are being used are TCP and UDP. So just keep it in your mind. On transport layer, as I said, transport is used to transport our data. So data is being transported using two main protocols are TCP and UDP. And by the way, we are going to cover TCP and UDP into their own section a lot in detail. So you don't have to worry. So let's head over to the next slide, which is talking about the network layer, and one of my most favorite layer of OSI network, because this is always talking about routing. That is why. So how the data uh, will be sent from source to destination in an optimal fashion. So let's talk about what this paragraph is saying. Third layer of the OSI's network is a network layer, which is responsible for facilitating data transfer between two different networks. Logical addressing happens over here. Okay. Apart from the logical addressing, we have physical addressing. In contrary to the logical addressing, we have physical addressing, and that is we are going to cover in the second layer of the OSI model. So you don't have to worry. Logical addressing happens here if the two devices communicating are on the same network. Then the network layer is unnecessary. The network layer breaks up segment from the transport layer into the smaller units called packets. If you remember, in a transport layer, whatever the data uh, we were using there were called segments. But as soon as these segments reach to network layer, now the definition has been changed and it is called packets. So in a networking environment, if two professionals are communicating with each other, and one professional is saying to another one, we are facing some segment issues. Just quickly, this thing pop into your mind. They are talking about the transport layer. But if the guy is saying, my packets are stuck or my packets are in a queue, we have to provide some quality of insurance to my packets, QoS to packets, then he or she is talking about the network layer. So you have to look out on this, okay? On the sender's device and reassembling these packets on the receiving device. So just like in transport layer, the segments, the sender receiving those segments and reassembling in the same fashion in the network layer. When this router is going to send one packet from source to destination router, they are going to divide into chunks, and they are going to reassemble those packets at the receiving end. The network layer also finds the best physical path for the data to reach the destination. This is known as routing. So this is the best definition about the routing. Where is the best path? Best physical path. This is the thing. Best physical path. Okay. For example, let's say uh, this is ISP1, this is ISP2, and these are somehow connected with some routers and routers. They are somehow connected with each other. And this is the server of job skill share server. And this PC wants to communicate with this server. So uh, the user will type www.jobskillshare.org. As soon as it hit enter, The information will be sent to these routers first. Now these routers has to decide on the basis of best path. Maybe for the ISP one, the path is much shorter as compared to ISP2. So that is why the path will be followed like this way to reach. So this is all things happening at network layer, where we are talking about the best physical path to reach the destination. And this thing is called routing. And by the way, routing we are going to cover a lot in detail. Network layer protocol includes IP, the Internet Control Message Protocol, and this ICMP. By the way, whenever you are going to ping use ICMP. And by the way, ICMP has one request and one reply. If you are going to ping, if you are familiar with the ping, that is fine enough. Otherwise, keep this discussion to this session. And once we will hit this ping its own topic, then we are going to talk about a lot in detail. But the ping is going to identify whether my this device or this device is alive or not. Even if this computers try to send a ping to this computer, the whole idea behind it is just it is pinging to check whether this system is up or not. Okay, so this thing is happening at network layer. Then we have protocols like IGMP, RIP, EIGRP, OSPF, IPsec suite. These all sections we have covered in CCNA topic. And my recommendation to you after you finish this program, this basics, this is going to be your destination, CCNA. And seriously, JSS has covered these topics a lot in detail. Even just the IPsec VPN, I think we have more than 10 sessions just talking about the IPsec VPN a lot in detail. So whatever these routing protocols um, happening on this layer is called network layer. RIP, EIGRP, OSPF, they all belong to this OSI layer, which is network. The second layer of the OSI model is data link. And I told you in the last slide, it is all about the physical addressing. Physical addressing. Whereas the network layer is talking about logical addressing. So let's read about this paragraph first. Second layer of the OSI is data link layer, which is very similar to the network layer, except the data link layer facilitates data transfer between two devices on the same network. So in network layer, when source and destination are on different networks, they are on different network, then network layer comes into handy. But opposed to network layer, we have a physical layer. Physical layer. This layer happens, or at this layer, when the source and destination are on the same network. Same network. Data link layer comes handy. So this is what it's trying to say, which is over here, when transfer between two devices on the same network. This is for uh, network layer. But if, for example, if we have two computers or two devices, they are connected with the, let's say, the switch. And by the way, switch is your intermediary device that is going to connect and make uh, these two computers communicate with each other with the help of switch. So this thing is called switch. So this is PC1, this is PC2, and PC1 wants to transfer some files to PC2. There is no network layer will come into play. There is no use of network layer. So network layer is always comes handy when these two systems are separated to each other, either physically or logically. Okay, and whatever the IP addresses are being used over here are different from PC2. If you're not familiar what IP address is, it's just like your ID card. If you are in the same city, you can communicate with each other. If you are in a different cities, of course, then you have to take a bus. You will go to that bus and then you will talk with that person. So this is just a layman example, just to make you understand uh, how physical layer or network layer works. I hope you get the idea. So let's talk about the data link layer takes packet from the network layer, and we know that network layer we deals with the packet and break into the smaller pieces called frames. So we came to know that at application layer, the term is called data. Then we have transport layer. The term is called segment. At network layer, the, it is called packets. But at data link layer, the data is called frames, as you can see over here. So like the network layer, the data link layer is also responsible for flow control and error control. So flow control and error control also happens in this intra-network communication. The transport layer only does flow control and error control for inter-network communication. And you might have a very clear understanding what is inter and what is intra. Intra is basically your local area network, LAN. You are physically or logically sitting there. But inter, you can take out from this word internet. And for the internet, you always have to leave your boundaries. So intercommunication is where geographically you are far away from each other. So this is where the transport layer only does flow control and error control when it is going to happen inter network communication. So LLC ensures the reliability of the physical connection. Okay, so when it comes to data link layer, we always deal with MAC addresses. MAC address, known with the many terms or names like NIC address, NIC address. It is also known as burn in address. It is also known as physical address. It is also known as hardware address. Then MAC address. MAC address basically is 48-bit address, and we will talk about a lot in detail. It is divided into 24-bit portions. The first 24-bit is used for uh, OUI, organization unique identifiers, like Cisco has own identification for MAC address, HP has own identification, Juniper has own identification, Microsoft. Okay, so these all vendors used first 24-bit to uniquely identify this company or organization. The rest 24-bit is for the client. For example, if you are going to manufacture one NIC card comes with a MAC address, and for example, your company name or organization name is XYZ. So first 24-bit is denoted to your organization unique identifier plus 24-bit you are going to randomly assign for your NIC card. Okay, this is not for the client, but basically when the client will install this NIC card, he will be having a very different or unique MAC address. So that is the whole idea of having MAC address. Then further MAC address is having two portions. One is LLC and then another one is MAC. LLC is used for the upper layer to communicate with the upper layer like IP, IPX. And MAC is used for the lower layer like physical layer, which we are going to cover in the first OSI layer in the next slide. Okay, so it is going to be very complex, so I will just leave it as it is. So LLC is a protocol that provides reliable delivery of a packet over point-to-point links. The standard protocol IEEE 802.2 is the most commonly used standard. LLC is used in the Ethernet network and other technologies such as wireless LAN. It specifies how workstations cooperatively share the transmission medium. The IEEE 802.3 standards specify medium access method known as carriers and CSMA/CD. This is called carrier sense multiple access with collision detection. In old days, when we were using hub devices, these days we have switches, Cisco switches. They are intelligent devices as compared to hub. Hub is used to known as a dumb device. If two computers, let's say one, two, three, four, let's suppose we have a hub. I will denote it with the H. If this PC1 wants to communicate with PC2, and then we have 3 and 4. So let's suppose if PC1 wants to communicate with PC2, whenever this information will be sent to hub will just throw this packet everywhere. Okay, and meanwhile, if no one is talking, then only PC1 and PC2 can communicate. Other computers will wait for some time. Once this communication finishes, then they only be able to communicate with other device. Just like a walkie-talkie. Okay, if you're talking with a walkie-talkie on a walkie-talkie, you will say, hello, how are you? Over. Then the second person will say, yes, I'm fine. Over. So over is the term. You can take it in place of CSMA/CD. So basically it tries to find the collision and tries to mitigate those issues. Okay, I hope you get the idea. A MAC address or physical address is a 48-bit number, as we have already talked about that. That identifies a specific network interface card. Every NIC has its own MAC address, which is usually printed on the back of the card. So as you can see over here, so LLC will speak with the network layer where we have routers, and the MAC at data link layer will talk with the physical layer, which we are going to cover in the next slide. So let's head over to the next slide, which is talking about the physical layer. And as the name suggests, physical, it means we are going to handle physically these cables. We have these RJ45 plugins, jacks. Then we have these hubs. We have these wireless devices, repeaters. Then we have these wireless media antennas. So the physical layer, this layer includes the physical equipment involved in the data transfer, such as the cables and switches. This is also, uh, by the way, switches here, it is not talking about the Cisco, the manageable switches. Manageable switches work at data link layer. When we are saying switches means these kind of hub. unintelligent devices. Okay, so they work at the physical layer. This is also the layer where the data gets converted into bit stream. And we know that bits are what? Bits and byte 1 0 1 0 1 0. So this is actually where these information will travel onto these physical cables, which is a string of ones and zeros. So the physical layer of the both devices must also agree on a signal convention so that the first ones can be distinguished from the zeros on both devices. So this is the whole agenda of discussing this OSI model. If this RJ45 cable, or sorry, CAT cable, let's suppose I have another CAT cable that I created, RJ45. So let's suppose whatever the data is transposed 1 0 1 0 1 0 1 0, whatever the data, for example, this is written A. So whatever the data that is converted into bits and binary will move over this physical cables, and when it will reach this my cat cable on other end, and if it does not know the convention, then I'm not going to receive the data, or even if I will receive the data, it will be a like gibberish. I cannot understand this language. So that is the whole idea of having ISO in place, International Standard of Organization, that will implement some rules that these bodies have to follow. So these rules will be implemented by this cat sorry this cable manufacturer, and the same rule is going to follow by this manufacturer, and then only the communication is going to happen. Otherwise, if they will not follow ISO standard, they are not going to communicate. Okay, so with that, our OSI topic comes to end here. And also, I'm going to stop this video over here because this is going to be another topic which is from the troubleshooting perspective. So I'm going to see you